Hi everyone, welcome to this session. So let's solve this very interesting interview question. It's a bit difficult for a perspective of a freshers, maybe a tougher side, but let's solve intuitively, okay, without writing, not writing so many of equations, okay. So this is may seems like a huge circuit, so just simplify it, okay, one by one. So you can see there is a constant current source I naught. You can assume any value. Let's say this I naught may be some, let's say 1 microamps. Okay, it can be any value. Just assume it is some finite value like this. And there is VDD. You can assume, let's say VDD as 5 volt. And we have all of these MOSFETs, and we have a RC section, and we have to plot V out waveform. Okay, so you can see where this up signal uh, is connected, and the up signal is looking like this, and down signal is looking like this. Okay, so this is down signal, so we can assume this Q1 and this Q2 is nothing but a switch. Okay, so Q1 and Q2 are nothing but a switch. Okay, so they are acting as a switch, and we will be assuming ideal switches. So the R on of Q1 equal to R on of Q2 will be 0. Okay, they are when they are like 1. Okay, so 0 ohm, so ideal switch. And when they are off, so R off of both of the transistor becomes infinity. Okay, so Q1 Q2 are switches, and they are ideal switches. Okay, we will assume that. Okay, so now you can see that uh, so it is a diode connected device. Let's say this Q3, so it will make a VGS here. So you can see this, if this is Q3, let's say this is Q4. So this Q3 and Q4 is a current mirror. Okay, and this is a similar device. So like this is identical device of Q3 and Q4. So this current will flow through this branch as well. Okay, right, so this will be I naught as well. Now you can see that this, let's say this Q5 and Q6. Okay, Q6 transistor. So you can see again there is a current mirror kind of thing, because here a VSG is developed, right? So again this Q5 and Q6 becomes in current mirror. Okay, so this I naught will be copied here. Okay, and again let's say this lower MOSFET is Q7. So again it is 1:1. So it is, if it is 1, so it is, will be 1 as well. Okay, so these two becomes identical as well. Okay, so if this current is I naught, so the I naught current will be flowing through that branch as well. Okay, so actually this except like this Q and Q2 are the switches, and all of the MOSFETs are acting as like a current source. Okay, so we can make the following circuit as the following circuit. Okay, and we have this up and down signal, so accordingly we have to plot the V out waveform. Okay, so actually all of them are current sources, so I can really neglect all of the things and making this kind of phenomenon. Okay, okay, this should be a PMOS, then should be NMOS. So this is up signal applied here, and down signal applied here, and there is another MOSFET, so another current source, and the current source will be same as this I know, right? And when it's I naught, when uh, so it will be I naught, yes. Okay, so then we have a RC branch like this, and we have to comment what is the V out. Okay, so this becomes our simplified circuit. Okay, so previously you have this complex circuit, and we can see that this Q3, Q4, Q5, Q6 and Q7 are nothing but a current sources, so we can replace that. Okay, and this Q1 and Q2 become switches, and we have a RC branch. Okay, so now I need to copy this waveform, and let's say pasting here. Now go into the intuitive portion. So this is 0 and this is VDD, and let's say this is our TSW switching, and it is on over, let's say, switching frequency FSW. So this is the time period of the switching, and you can assume this width, and this width is nothing but let's say 20% of your TSW, right? We can assume that, okay, 20% of your TSW. So so when, let's say, so this is a PMOS and this is the NMOS. So when you can see, let's say up to the T time period of, okay, let me, okay, so let's do here, okay. So this is our V out, okay. Okay, so now you can see, so when the PMOS switch will on, when the up signal becomes 0, right? When up signal is 0, then your, this was I think Q1, this was Q2, so Q1 switch will turn on, right? Turned on, so it will act as a short circuit, right? So up to that time period, and when down signal becomes VDD or 5 volt, then your Q2 will turn on, okay, unless it will be off and unless it will be off, okay. So in this time duration from 0 to that, let's say Tx time, we can see your PMOS is getting gate voltage as 0 volt, and your NMOS is getting 0 volt at its gate, right? The down signal. So we can see that this Q2 will be off and Q1 will be turned on, okay. So at this time duration, let's say this is Tx time duration, this time, not Tx, this will, let's say T1, okay. So let's say this is T1, okay. So at this time duration, what will be your equivalent picture? So you will have a current source of I naught, here your VDD, and this Q1 is turned on, so it will be short circuited, and this one is, this Q2 is turned off, so it will be open circuited like this, and here is a current source, okay. And now you can see here a RC branch is present, okay. So how it will happen now? So this is the transient phenomenon, okay. So this is transient phenomena. This switch is turning on and turning off in the transient, right, in the time domain. So this current will suddenly flow through that branch, right, as no current can go through that branch because this is open circuited, okay. So all of the current has to flowing through that branch, RC branch. So now here a voltage will develop. So how much voltage will develop? So a constant current is flowing through a resistance. So the voltage drop across the resistance will be nothing but I naught into R, and a constant current is also flowing through a capacitor. Then what is the voltage developed across this capacitor? So it will be Vc, and this is nothing but 1 over C integration I naught dt, and as your I naught is constant, so it will be nothing but I naught by C into T, right? So it will be T1 from this case, right? For this case, right? So this voltage is actually developing, right? So the voltage suddenly goes to higher. So at T equals, let's say this is some time. So at T equals 0 plus, at T equals 0 plus, what is the uh, voltage across Vc? So Vc will be 0, right? As our initial condition of the capacitor was 0 volt, okay. So it was previously uncharged completely. So at T equals 0 plus, your Vc becomes 0. So at T equals 0 plus, your V out is nothing but only IR, right? This IR, okay, like I naught R. So it will be jumping. So it will be jumping at from T equals 0, from 0 volt to I naught into R, right? Then it will try to increase in the ramping manner, right? Like as your T is increasing, your voltage will be increasing like that, ramping manner. Like the voltage across the resistance is constant, but the voltage across the capacitance is increasing linearly. So V out, if you write a KVL there, V out will be nothing but VR plus VC. Now this is constant and it is ramping up. So this V out will be ramping as well, right? So it will be ramping up. Let's say this value goes to here. So I am not interested the exact value of this node. It depends on the T and the capacitance value. So, but we don't interest, like we have like no interest about to like to find the exact values. Okay, we have some intuition and we have some wave shapes. That's all. Okay. So it will be like that. Okay, so this is the Tx value. Now at this time you can say you can see this is 0 volt, the PMOS is turned on, and here your NMOS is also turning on because it gets VGS, right? Like it gets high voltage here, right? It gets high voltage here, VDD. So we are assuming that it is developed some VGS that making it turned on. Okay, okay, right now. So previously we are assuming that it is getting some VSG, so that it is turned on at when this is 0, and now we are assuming as well when this voltage goes high, so it is turning on this Q2. Okay, so now your equivalent picture, let's say this is T2 time. So from T greater than T1 to less than T2, what will be your equivalent circuit? So equivalent circuit will be nothing but the following. So both switches will be shorted, right? And both current will flow as I0, I0. Okay. Now here we have same RC. Now tell me, what is the current flowing through this branch? So if this is I0 and if this is I0, now if you write a KCL there, so you will find there is no current flowing through that branch as well, right? Suddenly, okay. When your both switches are turned on, no current can flow through that branch, okay, flowing through these RC branches. So the current flowing through this, let's say IC, like this branch is 0, right? So suddenly your current becomes 0, okay. So there is no issue. So what will happen? Suddenly your VR will be nothing but 0 volt, right? Because your IC becomes IC is 0 and your R is finite, so 0 into R will be 0, right? Now what about the VC? So VC, the like as this is open circuit, it will be looking like the following. Okay, so we can assume this is there is no current. Okay, so now this VC can hold its previous voltage. Okay, whatever it is stored previously, so it will hold that voltage, and this resistance becomes short circuit. So your V out becomes VC, and your VC cannot change, like it can hold its previous voltage, so it will hold the previous voltage like this thing. Okay, right? It was previously I naught by C, into T1. Okay, so it will hold its previous voltage. So what will happen? It will hold its previous voltage up to T2. Okay. Now what will happen after that? So again you can see now your PMOS is turning off now, right? Because this your up signal getting a VDD here. Okay, so this PMOS now is turning off. And what about NMOS? And NMOS is getting the 0 as well. Okay, 0 volt as gate. So we are and both of the MOSFET is getting off, right? Like suddenly after T getter. Okay, let's say this is so this is TSW, right? This is TSW. So when your T is greater than T2 and less than TSW, so then your both Q1 and Q2 is off. And here and previous case Q1 and Q2 both 1. Okay, both are 1. And at the first case I write to make like forget to write this. So your Q1 was turned on and Q2 was turned off. Okay, so now if both this is turned off, so what will be the case? So here is I0 and this is open circuit, again this is open circuit, and here is I0. So similar case, it will hold its previous voltage, right? Because no current can flow through that branch as well, because these two currents, this current and this current is becomes 0, like no current can flow through that branch, and your RC is getting 0 current as well. Okay, so again it will hold its previous voltage. Okay, right? So it will hold its previous voltage. It is nothing but 1 by C I0 into T1. Okay, so same voltage will be hold. So there is no current, but here the both of the current through that branch like this branch is getting 0. Okay, now so it will hold up to that thing. Now what will happen after that? So again you can see your this voltage is getting 0. Your up signal is getting 0 and your down signal is getting 0 as well. Up to that, let's say this is T3. Okay, this is T3. Now you can see that previously it was at this voltage, the output voltage. Now your PMOS is again connecting, like the PMOS, the Q1 switch is again conducting. Okay, so now if you plot at T equals T greater than TSW and less than T3, so your Q1 is conducting again and your Q2 is off, right? Because your VG, like the down signal is 0 volt and your up signal is also 0 volt. As it is PMOS, it is conducting. Okay, so now how it will behaves? So it will, be the equivalent picture will be like the following. So it is conducting, this is VDD, this is I naught, and here is this kind of thing. Actually this current is also 0, as that a switch is not conducting. Just this is the equivalent picture. Okay, just don't get confused. Okay, so again it will charge, but how much it will charge? So previously it was some charges, and then in top of that it will be having some another voltage across it, right? V out. So it will be nothing but IR plus again the previous voltage of IC, VC of 0, like previous, and plus 1 over C IC into T3. Okay, so this voltage will be the case. And again as it was in this case, so it will rise again suddenly and it will be ramping up like this. Okay, and again it will hold up to that next 2 TSW. Okay, so this is 2 TSW, right? 2 TSW, and this will continue. Okay, so this is TSW and this is TSW. So now I am ramping up, like concluding everything. So this was our circuit. This Q5, Q3, Q4, Q6 and Q7 acting as a current source, and your Q1 and Q2 are the nothing but a switch. Okay, so we just redraw reduce the circuit and we get this kind of circuit. Okay, where the switches Q1 and Q2 is controlled by this up and down signal, and we have analyzed the circuit using this up and down signal, and we are getting this kind of phenomenon. Okay, so this kind of waveform, and it will be continued. Okay, like if you go for your TSW 3 TSW, so it will be increased value. Okay, so this is your complete circuit. So I am drawing to another color, let's say. So suddenly it will go to I into R, then it will be ramping up due to the capacitor, as only the Q1 transistor is on, so PMOS is conducting. Then both of the MOSFET is conducting, so no current can go through the RL branch, the RC branch. So it will be like the RC branch will be getting 0 current, so it will hold its previous voltage. Okay, so it is 0 current IC, so it will hold its previous voltage. So both are on, and when the both switches are off, then again the IC becomes 0, so again it holds its previous voltages. Okay, now for the next cycle from T greater than TSW to T3, again it will get a sudden current at instant, but it was previously charged some voltages, so it will be again jump up to some I into R, then it will jump up into I into R again, then it will be ramping up again and it will hold for the 2 TSW, and this continues. Okay, so this with IR is same. Okay, and this with IR is same. Okay, and as TSW T3 like that, this duration and this duration become same. Okay, so this voltage will be the twice of this voltage. Okay, understood? So if this is Vx, it will be 2 Vx. Okay, so this is the thing, and slope will be same for the both of the case, because everything is same. So your slope will be nothing but I naught by C here. Okay, the slope will be I naught by C, and here will be I naught by C. Okay, this slope, the ramp slope. Okay, I think I made a small mistake there during this time T greater than T1 and less than T2, because like the analysis was correct, but the waveform is not fully correct, as when the both of the like the switches are on, so this IC is 0, so the V out actually will drop by this IR drop, right? Because the previously your V out was VR plus VC. Now when the both switches are closed, then both switches are closed, then no current can go through, so actually your VR will be dropping, right? So your VR becomes 0. So at the instant when both of the switches is turning on, then your V out becomes a VC only. Okay, so I think I have told correctly, but the drawing is not correct. So the analysis will be same, but the waveform will be slightly changed, right? So actually, let the color can be let's say this is the color, and this at this time duration both are turning on. So actually this will be dropped by IR. Okay, so this will be like this. Okay, so everything is same. So this is IR and this is also IR drop. Okay, I into R drop. Then again, so it will be not be like this. So it will be from here to there, it will be IR, right? So it will be, let's say, then it will be okay. So this is your final waveform. So this height is I dot R, and this is your whole V out, and this is also dropped by your IR. Okay, so it may be okay. Let me do it correctly. So let's say this height is on small block. So let's say this is okay. Let me draw correctly. So let's say, so now this much has to be dropped. So this is the drop again. So it will be holding up to that value, up to that time. Then again it will be jump up to on IR, right? So it will be like this. So again this height is also I naught R, and this height is also I naught R. Okay, and this height is also I naught R. Then again it will be like this. Okay, then again it will be dropped by I naught R, and it will be like this. Okay, so this will be your correct waveform. So previously the waveform was not correct properly, but this is the correct waveform. Okay, thank you.